Hello, everyone. Thank you for joining us this evening for what proves to be a fascinating talk by Brittany Cox about restoring the museum's 19th century singing bird box. My name is Paula Reich, and I'm the manager of gallery interpretation and learning at the museum and the curator of the exhibition Rare and Wondrous Birds in Art and Culture 1620 to 1820, where the box is currently on display. And you still have a chance to check it out. The exhibition is on view through July 25th. Before we go any further tonight, I'd like to acknowledge the land that the museum is on. The Toledo Museum of Art is located on ancestral homelands of the Kickapoo, Erie, Ottawa, and Seneca. We recognize that many other Native tribes have also conducted trade on and called this region their home, including the Fox, Lenape, Miami, Ojibwe, Peoria, Potawatomi, Shawnee, and Wyandot. We at the Toledo Museum of Art acknowledge and honor the past, present, and future lives of Indigenous peoples in the Toledo area and thank them for their resilience as stewards of the land on which the museum's campus now resides. Tonight's event is kind of jointly related to the Rare and Wondrous exhibition and our temporary public conservation lab that we're calling the Art of Conservation. The box with bird automaton was given to the Toledo Museum of Art by the museum's co-founder and benefactor, Florence Scott Libby, in 1933. As I mentioned, the box is displayed in the Rare and Wondrous exhibition, which explores the cultural impact of birds brought back to Europe from around the world during the 17th and 19th centuries as European world trade and colonialism greatly expanded. The little mechanical bird is covered in real hummingbird feathers, birds native to South and North America, not Europe. And its song is based on that of canaries, which originally came from the Canary Islands off the northwestern coast of Morocco. The box may have been in working order when Mrs. Libby had it, but it hasn't run in many years. That's where Brittany Cox comes in. And I'm going to turn it over in a second to TMA's head of conservation, Suzanne Hargrove, to talk a little more about conservation at the museum and to introduce our speaker for the evening. But first, a reminder that during the presentation, you can ask questions in the Q&A box at the bottom of your screen or in the chat box, and we will try to answer as many of them as possible at the end. And now I'll turn it over to Suzanne.
Greetings, everyone. Thank you so much for coming to this exciting presentation this evening. I am Suzanne Hargrove. I'm the head of conservation at the Toledo Museum of Art. And I had the great opportunity to work with, both listen to Nico Cox as a presenter in past conservation conferences, national conferences, where she has spoken about the treatment of automatons. Brittany Cox, Nico to those who know her well, received her training from the West Dean School in the United Kingdom. So she worked there, she learned the treatment about the treatment of automatons and mechanical items there. But prior to that, she also had a considerable number of years of training as a horologist in terms of treating clocks and watches. So she has considerable experience and is recognized worldwide for her expertise in the treatment of automata and clocks. So, so delighted. I had the great opportunity to take our bird box to her studio, which is was in the Seattle area, and see her workshop and talk with her about the treatment of the bird box, which was quite exciting. And then we had a more excellent opportunity when Nico actually brought the box back to the museum, and we had the opportunity to talk about its treatment and look at it in action, which you all have the opportunity to do at the Wondrous Bird exhibit, where you can see a video of Brittany Cox actually winding the mechanism for the box. So it's quite exciting. I'd also like to mention, if you're interested in conservation, you have the opportunity to see the work that we do, not on all types of artworks in the collection, in the Art of Conservation exhibition. And I'd also like to let you know, if there are people who are interested in participating in an activity, we are actually having a volunteer experience that will occur in July, during the month of July, where we are inviting volunteers to work with us on the cleaning of the cloister, which is not a little bit of a departure from this evening's talk, but I wanted to make sure that you all were aware of that. So without further ado, I'm so excited to have Brittany Cox talk to you about the conservation treatment of our singing bird box. Welcome to the program.
Thank you so much for having me. This is really a privilege and really exciting for me. I was thrilled at the opportunity to actually do the treatment of the bird box, and even more thrilled now to actually share a lot about that process and a bit of history with everyone. I'm going to start my screen share. I will say that I'm much better at old technology than new technology, so please bear with me if there's any technical difficulties as I go through this. Here we are. Okay. So, Rare and Wondrous Singing Birds, the Toledo Museum of Art, Bruges, box 190. So again, I just want to thank you guys for having me here today to give this talk. I would love to be able to do this in person, but thank goodness for new technology allowing us to share these things to a much wider audience now. I think that's one good thing that's come out of all of this. This particular object has a very long history in the sense that there's a very tremendous lineage of fascination with birds and bird culture, as well as the manufacture of these types of mechanical bird objects. So I'm hoping to give you kind of a background on some of these. It's going to be a brief history with some highlights from my favorite objects, and then also some of the work done on the treatment. So this is an image of a beautiful display. This is from the Natural History Museum in London. It was part of a much larger exhibit from 1851 by a gentleman named John Gould, who was famous for making these types of displays. So the world was fascinated with these types of birds. So our story really begins with public enchantment. Even though these pieces were originally taken from the natural world as taxidermy items, they ended up finding their way into the hearts of many in many different forms, from displays onto everyday adornments. So we start seeing birds and beautiful feathers arriving on earrings and things of that nature. And these are actually from the mid-18th century, about the same time that our Toledo box was manufactured. They even found their way onto hats. So these are just a couple of fun examples that I really enjoy from bird fashion and bird history. And these are mid-18th century, one of these examples is mid-18th century, and they actually go up into the 20th century. The one on the right is from 1911, and this is actually in the Metropolitan Museum of Art there on the left. And then the V&A on the right is the 1911 piece. But for us, our little bird was actually in development much earlier than any of these hats or adornment items. So our little protagonist is a tiny mechanical head-turning bird. It's got wing flapping, tail bombing, song singing, and it was made around 1820 and has over 30 individual parts in it. So when dressed, he actually wears over 100 individually applied feathers. And those little feathers could actually lose a size contest to a grain of rice. So, and that bird is smaller than the first digit of my pinky finger. Those are a number 5 pair of tweezers, and watchmaking, those are most often used for doing manipulation of hair springs. And hair springs, they get the name from basically a blade of your hair. So it's a very, very fine spring. If you look at the size comparison there, you can see this is a really small and delicate object. Each component of these tiny birds and their mechanisms was handmade. And the earliest versions date back to 1784, 1785, and they were invented by the ingenious horologist Pierre-Jacques Droz. He actually was famous for making some incredible automaton, much larger in scale than these singing birds. There were three of them: a writer, a draftsman, and a piano player. But he perhaps is most well remembered for his singing birds because they were beloved by all. Now, the feathers that adorn these birds, these original ones from the 1700s, they were all taken from the gorgets and the heads of hummingbirds. These feathers had these incredible properties that allowed them to glitter like gold and ruby and topaz and emeralds. The iridescent colors that are actually generated by these gorget feathers are the result of the reflection of incident light. And this is caused by a microscopic structure inside the actual barbules of the feathers themselves. So the refraction works a lot like a prism, and it splits into these rich color components. And as the viewing angle changes, the refracted light becomes visible in a glowing, shimmering, iridescent display. Hummingbirds use these mostly for fighting off territories and attracting mates. But what's incredible about these feathers is that they don't deteriorate due to light interference. A lot of the time, what happens with feathers that are made from pigmentation is that they fade. And what's incredible about these feathers is that they're actual little crystalline structures that are generating the light. So many protected and exotic birds, this is a violet-crowned wood nymph, also provided these like incredible chartreuse and violet feathers for ornament. So these birds were considered quite valuable and actually even used as currency in some cultures. And what I think is interesting about feathers, I'm kind of a feather fanatic, especially I think working with them, is that feathers actually can hum, they can vibrate, they can whistle and pop, and birds use them to communicate. And a bird's feathers actually weigh more than combined than they do the entire skeleton of a bird, which I think is really fascinating. And if the world's feathers were laid side by side, one by one, their entire combined length would actually trace a path to a distant celestial horizon. That is a lot of feathers. But the world has far fewer feathers these days. So since we have fewer of these magnificent birds, birds are certainly, because they were so prized for their beauty and their feathers, we've decimated a lot of the bird population. But these rare, illustrious, and magical feathers that adorn the bodies of our little balloteers are quite delicate and very hard to preserve. And so refeathering a bird and keeping those feathers intact is one of the harder components of my job doing this work. Selecting and preparing the feathers for a bird is meticulous and quite time consuming. Each feather is chosen for its shape, its size, and especially its color. Each one is trimmed and prepared for placement on the body. So each tiny feather is shaped for a particular area. So the wing feathers are going to be different from the head feathers, from the chest feathers, from the back feathers, and from the tail feathers. Our little friend sits perched atop its golden nest, a small mechanical world beneath. There, it's all to support its performance, which has been written and enacted for over 200 years. This particular piece dates back to 1825, you're seeing here, and is by the same maker as our Toledo box, and is a little bit earlier. In the beginning, these birds were adorned like lavishly colored baubles, and really a creature all their own, whose whimsical song was meant to mirror those of nightingales. This piece, a paperweight actually, was titled Views of Switzerland. It is by Charles Abraham Brugier as well, so this is again in the same maker of the family that the Toledo box belongs to, and it is adorned in gold, marble, mother of pearl, and painted enamel. They were magical, enchanting, and beloved. From ornate objects of art became objects for the pocket. So suddenly you had incredible watches, one maker being Jacob Frizard, who is a favorite of mine. If you're interested in bird history or mechanical bird history, I certainly recommend looking up that gentleman. But this particular piece was made by the brothers Rochat. They were famous brothers who created some of the most opulent automata, singing bird automata of the time. So suddenly we have these birds popping out of watches, pistols, necessitaire cases. So these are like the thimble and sewing cases a woman would keep on her dressing table, and bracelets as well. This Rochat brothers watch was actually made in 1820. The set of singing bird pistols was actually made by the Rochat family as well. This is still quite respected as one of the greatest feats of engineering from this era, and recently sold at Christie's at auction for over $5.8 million. To this date, nobody has been able to recreate these pistols. Many people have tried, but replicas of these exact pistols and their mechanisms has still not happened. Each pistol contains over 600 parts, and there are different mechanisms that have to act in tandem in order for that bird to pop out of the end of the pistol. So when you squeeze that trigger, a chain reaction occurs so that that bird can come out, it can sing and return inside the pistol without being hit by that little door. It's a pretty incredible work of art. Now, some people might know Peter Carl Fabergé. He was the goldsmith to the Tsar Nicholas II of Russia, and he made this incredible, even he got involved in singing birds. He made this incredible singing bird display called the Orange or the Bay Tree. And it was a homage really to Robert Houdin, who was a famous clockmaker and a magician in the mid-19th century. He traveled all throughout Europe with this particular trick you can see on the left, which was known as the orange tree trick. And so Fabergé, taking much of his inspiration from the masterworks of the past, recreated the orange tree in this bay tree display, but included a little singing bird at the top. You can see just popping out of the crest there. And that bird was made in 1911. But I would say the very most popular form of singing bird automata came in that of boxes. These were much more accessible to the general public. So this particular box was made by the firm of Puget & Capt, which is actually a little bit more on the rare side. And the box was made by Jean-Georges Ramond and is dated 1815. So this is quite an early singing bird box. This would have, been kind of on the back of Jacques Edros, who invented the singing bird. And this was likely a christening gift for the 19th century Ottoman prince Shahzad Mumhad. I'm pronouncing this terribly wrong, I apologize, Mohammed Saladin FD. And this was in 1888. So this particular box would have been purchased and then adorned later with all of these diamonds. And the monogram adorns the lid of this particular box of this son, who was the Turkish Sultan Abdul Aziz's son. So these particular types of objects were given a lot of the time as acts of diplomacy and were given as a way to ensure favor from kingdoms or to celebrate a special occasion. So the box became quite a popular item, and it evolved from these types of opulent boxes. Now this is actually a solid Varigold case, so this has many different types of gold. Our Toledo box is a silver gilt box, so similar in style and decoration, except that it is a gilt box. So that would have been a slightly less opulent box of the time. And later boxes were much more simple. So these were simpler in their design, not only in their decoration and the cases, but in their mechanism as well. So this is a late 19th century bird from the collection at the Cooper Hewitt Museum. And this particular box is a tortoise shell box. And this would have been a molded tortoise case. And the mechanism would be inserted from beneath. So in our previous box, the mechanism would have been put in through the top. In later versions, the mechanism was actually put in through the bottom. And so there's a base plate that the mechanism screws to and actually goes into the lid and in the top part of the case in one. Here's another. This is another later one, and this is in the Museum of American History. Now, both of these boxes are exceptionally different. This is another 20th century box, but you can see there's a lot of pretty lavish decoration here. It's adorned with garnets and enamel, and it's made of sterling silver. And it's quite different, but this one in particular is interesting because it signals kind of this move from an exotic feathered bird that is unlike anything that we know, that is kind of based on these beautiful shimmering birds, these endangered birds of the past, to something that's more familiar, so a tanager or a robin. So moving from these incredible shimmering hummingbirds to something that we might actually observe outside in the natural world. And in this case, they actually did take a bird from the natural world. So this is an interesting example. I didn't cover many of these because in particular, this one is quite an interesting piece in the sense that they've actually taken a scarlet tanager and they've taxidermied it. Now, they did this with a lot of exotic birds as well, but these were always done for larger displays. So this would have been in a cage. And other versions of this would have been several birds displayed on top of foliage. One firm that was famous for that, which actually made this piece as well, was the Bantams firm. And the Bantams firm really found its peak in 1850 and post 1850 with the invention of just the going barrel mechanism. And so we start to see these larger and more simpler cage displays with these taxidermied birds more often after that date. The going barrel mechanism is much simpler in design. It has a wooden set of bellows and a going barrel with no fusee, which our earlier boxes had brass bellows and had a fusee mechanism. Now, I can talk a bit more about that when we get to our actual treatment of the Toledo box. But in this case, I just wanted to give you an idea of some of these later, more simpler mechanisms. I'd be happy to talk more about that during the Q&A. But I wanted to share some examples of some of these. So that box is quite interesting. This was actually owned by a gentleman that had two boxes, and one of them was quite sweet and mellow. And the second one, which you just saw, I always joke that I call him Panic Attack because I feel like every time I watch him, I'm going to have a heart attack. But he liked the juxtaposition of these two very distinct personalities of these birds. Now, what I think is really interesting is that each one, even made by a different maker or the same maker by the same firm, but maybe a little bit later in the series, has its very own personality. And I think looking at the bird feathers on those previous birds really helps to show how distinct each one is. Each one was hand feathered, each one was handmade, every component was handmade. So in comparison, please contrast Panic Attack to this next singing bird, which is also by the Brugier firm. Our Toledo box is by the same firm, and you can see what I mean. So you can see this box, which is actually about 100 years earlier than the one you just saw, is very different in its personality, its song, and even its decoration is quite different. The later box, if you noticed, had some glitzy hummingbird feathers, very sparkly. This box here, I feel like the bird is definitely the star of the show, and really the biggest star is his song. This is probably my favorite box I worked on. Not that the Toledo box isn't also an absolute favorite, but this one in particular I really enjoyed, I think, because the bird was quite modest, but the song was so cheerful. So treating the Toledo's Brugier box number 190. So here's our box. This, I believe, is about circa 1835 from the Brugier firm, which was in production from about 1788 to 1862. That firm, well, that's the dates of Charles Brugier himself. The firm actually continued long after that. His son Jacques took over, and boxes continued to be made after this period. But this particular type of box with its decoration, its style, was most likely around the period of 1835 because it's numbered, and it's numbered 190. And when they would make these boxes, we could see how many of these were made in a year, and perhaps it was only 10 boxes a year. So even though these were technically mass produced by a firm, they were not made quickly. As I said, each piece was handmade, so nothing was interchangeable. Each one was really a one-off, even though they were made in a series. So this was silver gilt, which means that it was a sterling silver box, and then it was gilded with gold. And you can see that a lot of the gilding has really worn off at this time, and it's oxidized as well. The little slide lever, which operates the box, which is on the front, was made of brass. This would have also been gilded originally, and it would have matched the box in a cohesive way. You can see there's a beautiful enamel scene on top, very pictorial, with mountains and an ocean side. And it's engraved with engine turning as well as hand engraved motifs. And it's an interesting box because it has these rounded corners as well, which is quite lovely for this period. And sometimes, you know, a less expensive box would have been maybe just square, but this one is quite lovely in all of its detail. You can also see that the key there has its original shank, but it had lost its decorative top. So what's lovely about these keys was actually, it was made with a ratchet, an internal mechanism, so that you couldn't wind the box backwards, which is often what happened with later boxes. They didn't provide these fancier and more sophisticated keys, so people would wind the box the wrong direction and break something. Here's the mechanism. It has three separate dimensions really to its running. So we've got the bellows there on the left. It has pumping plates and pumping arms, which pump the plates. It has its lid, and underneath that lid is what I like to call the nest of the bird. Our bird is sleeping there. It's kind of in hibernation before it was worked on. And then on the right, we have the lid lift part of the mechanism. This is all responsible for the lid opening, the bird rising. And then inside, we have the components. The fusee you can see is actually there on the lower right part of the image. That chain is part of the fusee mechanism. This is connected to the barrel and provides a constant energy source. So when I was talking about going barrel boxes later on, post 1850, that is when this fusee would no longer be included in the mechanism, and these were much more simple after that date. But you can see those different components here in the system. And each one of those has to be corrected and worked out in order for the box to operate together. So everything kind of happens in a series and works in tandem. So you can't fix one element of the box and expect that the other parts will function. Everything has to work together in harmony to support the message and the song of the bird. So you can see, here's our little bird. This was actually after feathering and doing some of the finishing work, but I was at the point of making adjustments to the lift and getting the bird kind of in its proper orientation to come up and sing at the right time. This requires a lot of critical thinking really and reverse engineering, but where I think is going to be the most exciting part of this process is actually talking about our little protagonist, our beautiful little bird. So here's how the bird came to me. He looks a little worse for wear. He's missing a few of his feathers. And he's really just hiding in there, isn't he? So this one bright feathers were really covered in a layer of grime and dust. And the living bird feathers that adorn these bodies, they actually have a natural mechanism that maintain the plumage. So it's a lubricant that's produced inside the body of the bird. And as the feathers have left the body, there's only so long that these lubricants, these natural lubricants, stay active in the feathers. And so once they leave the bird, the natural process of deterioration starts as the lubricants degrade and are no longer replenished by the living bird. So it's very difficult to clean these bird feathers. So not only was he in a little bit of rough shape for his plumage, he was actually had some internal faults as well. Now, this is a pretty common problem with older mechanical birds. The delicate inner workings can fail, and repairing an internal bird mechanism requires dismantling the bird and the some 30-odd components that make up its form. So once these are corrected and cleaned, the bird also had to be reassembled. So you can see there that I've taken off the two half shells and got him open so that I can examine what's going on inside. And here I wanted to show you how the internal mechanism actually works. There's a series of levers that runs up inside the bird, and when those are actuated, they rotate the head, they bob the tail, and they also operate the beak and flap the wings. So there's quite a lot going on that this little internal skeleton is responsible for. So once repairs on that part of it are completed, the skeleton is then enclosed by these two shells, and placing these shells on the body is a bit of a finicky process because there's a lot of things that have to link up. Now that includes the flapping of the wings and getting everything oriented for the tail and the head as well. And so on the left, you can see that I did my best to save the original feathers. So those were all really salvaged. And what's wonderful is that sometimes when these were made, they would use a very thin layer of vellum, and they would actually adhere the feathers to the vellum shell, which would then be applied to the bird. This allowed for easier access for repair or for adjustments when it was being manufactured. But very fine tweezers, like those number 5 tweezers, have to be used to pluck up each feather as they're so petite. And a careless exhalation of breath can cause them to flutter into the air in different directions, rarely to be seen again. It is quite an often occurrence that I will find a shimmering feather stuck to my eyelash or something by accident, but usually that's not a historic bird feather, but perhaps a replacement bird feather. That's when you're in danger of really losing your feathers, as if they're not attached to a piece of vellum here, or you're refeathering from scratch, because the original bird feathers were not salvageable. And refeathering a bird from start to finish can take up to 15 hours. And as I said before, usually requires about 100 individually applied feathers. And the placement of each of these feathers is critical, because you can't impede the motions of the bird as you put the feathers down, which is a very easy thing to do. The springs inside the bird that actually make everything operate are also quite fine, about the thickness of a hair as well. So selecting and preparing these feathers is quite time consuming, because each one is chosen for its size, its shape, and especially its color. You can see here that I've replaced the original feathers as much as possible, and then I've done a bit of infilling to make up where feathers were missing. An entire panel of a wing was gone, and many of the feathers on the head and the body itself were quite deteriorated at that point. So here he is finished, and this is when I began to move on to the mechanism. You can see there he is on the left. I'm getting ready to place him, and there he is placed on the right. So in addressing these other systems that actually support our birdsong, our little protagonist, there were several critical failures. Now I'm just going to cover a few of them. But in this case, you can see that there is, if you look at the red circle, there are pieces, or a piece that is missing from this mechanism. And that was for the lid lift function. So the way that the lid opens and closes, there's a small reduction gear train that basically transfers that motion up to the lid into a lever, which raises that lid and lowers that lid in a particular timing. And there was a pinion that was missing, and that had to be made from scratch. Now, making that pinion can be a little bit difficult, because you don't have the best way to take measurements with the plates and everything inside. So I made a brass one first, and then adjusted all of those parts of that particular pinion. And once I had a good blank that I felt was appropriate, I measured that. And then from that, I cut the steel pinion and made that into a new pinion, which you can see placed in the mechanism there with the arrow. Now, another part that was broken, there is a rack that operates a beginning part of the sequence of the lid lift. Now, the lid lift is enacted actually by pulling the lever on the outside of the box, and that pushes a rack that engages with a train, a gear pinion situation, which actually then engages with that reduction train on the side. And the pin was sheared off. So I had to cut a new pin. You can see the top pin in the right image is the broken pin, and then the new pin is there on the bottom that I cut on the lathe. And then that was pressed into the rack there. And moving on from there, the next part of my job, from the lid lift and the mechanism that actually supports the bird on the top, was working on the motor inside. And really the most critical part of this system is the cam stack. So the cam stack is pictured there on the left, and you can see it disassembled on the bottom. And this series of cam dictates the motion of the bird, the depth of the whistle, the plunger in the whistle. Basically what generates the bird song is a slide whistle. It's that same whistle that we all, hopefully children still have as a child when they go to the fair, but it's that type sound. And basically you change the depth of the plunger in the whistle to generate a particular note. And that note is dictated by this cam stack that you see on the left. And it's a sprung-loaded cam stack. So as that cam stack is rotating and it's in the mechanism functioning, it's actually moving up and down, and runners are running up and down on this cam stack. And there's a very delicate spring mechanism inside that allows this to function, and it has to work in time with the rest of the mechanism. So this was another part, was dealing with the cam stack and getting that all taken up and fixed. You can see here the motor in progress. Our cam stack is running there. You can also see the pumping arms on the right. Those are oscillating. That's what's going to provide the power to our bellows mechanism, which provides the lungs of the bird. So there's our motor on the right, and you can see the bellows, or sorry, the motor on the left, and you can see the bellows there on the right. And the bellows are also quite another complicated system. I know I'm breezing through this, but we're on I think I'm almost out of time actually. But here we've got our bellows there on the right, and this particular system is a whole nother enclosed pneumatic system. Now, I think this is a good diagram I put together to kind of give you an idea of how this works. Now, there's two places where air goes into this bellows system. Now, there's these two blue arrows at the very top, and they're showing it's taking in air through the top, and then there's a slot on the right with an arrow coming in, and that's another intake. Now, at the bottom, you see that there's also air coming in, but that's really releasing air more than anything. That's the reservoir down at the bottom. So the two yellow arrows are the actuation. That pumps up and down, up and down. And as it pumps up, it draws air into one chamber. As it pumps down, it draws air into the other. So there's an overflow spill valve that's on the center that's in the center chamber there. And that lets air spill into the reservoir. So the reservoir is always pressurized. There's never a time in which this system doesn't have a constant air pressure. That allows the mechanism to generate a crisp, clear, beautiful voice for our bird. So we have to have this constant pressure and this constant intake. Once the bellows are full and the reservoir is supplying this constant pressure, that air starts to go into our slide whistle, which is outlined in green. So the green, you can see there's two places where air is being given to the slide whistle. There's a slot on the bottom, and then there's the valve, which is orange. All of our valves are orange on the top. So there are two places that the air is, the whistle is getting air. There are two places for intake, and we're able to have this constant pressure system. Now, a critical part of this system is actually having these valves. Now, the valves are these absolutely feathery, light, floaty devices that have to be mirror polished, and they create this seal on the brass. And as that suction, as that pressurized system, air is moving from one into the other, those valves have to snap closed so that air cannot leak or transfer between chambers when it's being actuated. This is really tricky because once you get everything in place and the valves are pushed down and sprung loaded, right? Everything's where it should be. You then actually have to cover the bellows. And that is done with something called Zephyr, which is a pressed goat intestine. It's a fine membrane that is treated, and it's scraped very, very, very thin. Now, Zephyr means air in Greek, and I think that's very poetic here that they're using that for these lungs. But once you seal up the bellows chamber, you can no longer test the valves inside. And so if there's anything going on, there's any little critical failure that could cause something to go wrong or to fail, you cannot address it. You have to start over again, and you have to cut open those bellows and begin from the beginning. You can certainly diagnose based on airflow or sound or how the thing is operating, maybe where that fault is coming from, but there's no way to address it without actually cutting it open. There are times when I've seen bellows where someone has maybe made a slit in the chamber and tried to address just one part of it, but really that is not anything that is going to hold up over time. And really what the most important thing about working with these objects, especially as a conservator or horologist, is that you want to give these objects longevity. You want to make sure that you're interfering as little as possible with their performance, with their life, with their progress, because every time you interfere, there's inherent risk that comes with doing that. So when you do this job, you want to do it right the first time, and you want to do it well so that it can be enjoyed for many generations to come. Certainly there's maintenance and things of that nature, but you want to be sure that the bellows system is intact, because often, you know, I mean, what is a bird that can't sing? You need a bird to sing. And here we have our mechanism completed. Here's our beautiful little protagonist. He's perched atop his nest with the whole system there supporting him. He runs a little fast. Now you're going to see that in the next video. What was interesting and a later challenge, you know, once I had all these other systems going and I saw how he was functioning, that was when I would find out that the spring, which I saw was not original from the beginning, was actually too strong. What often happens with these boxes and what people do, because I don't think they quite understand the delicacy or maybe the interactivity between the systems, they overpower them because the bellows are requiring so much power to pump. They don't need a lot of power to pump when the system is properly, everything's balanced in it. So a lot of times an overpowered spring is put in, and when you fine tune everything and you get everything working the way it should, it's actually supplying so much power that the thing runs too fast. And when it runs too fast, you miss out on some of the beautiful subtleties of the song that this mechanism can generate. And that has to do with the trill of the bird, a very fun and subtle change in the way that the bird is singing and the note. It's exquisite when it works just the way it should. But in this case, this was a larger, stronger spring than necessary. And my hope is that eventually that will be replaced with a lighter spring that's much more appropriate for the mechanism. So our bird can sing as beautifully as he was made to, and will continue to for hundreds of years. So here it is finished. You can see the box looks much brighter. Now, I think it's interesting to note that it obviously is silver, but it has this kind of golden quality to it, and that's the gilding that's left. And you can actually see that gilding on the inside. That there where that 190 is scribed on the top left part of the image, you can see that that is actually that gilded surface. Now, the whole box would have been that way at one time. And now there's kind of this beautiful, soft, golden glow that comes off of it. I kind of like it that way, actually. I think it's lovely. This is to show the key, which cannot be wound the wrong way. He's also fast, also a little sugar high, maybe like a hummingbird would be. You can see our fusee winding there, compensating for any discrepancies in our steel spring. So constant power transfer there. You can see the cam stack. We've got our bellows system. We've got a spring on top of our reservoir, Rougier 190. There it is marked on the bottom. And our beautiful enamel lid, and our bird. There he goes. So we can see our little lid lift mechanism there on the right. We have our rack, which is operated by the lever when you open the box. We've got our bellows, pumping plate mechanism there. An absolute feat of engineering. Try imagining making something like this now without CAD. And all by hand. And I will say by candlelight, don't forget these people had no electricity. This is probably what we should all be showing for our time at home during COVID, something like this. Who knows what these people would have been making if they had been stuck at, actually they were stuck at home. well, anyways, with our resources, I wish we could teleport ourselves back. Thank you.
Thank you so much, Nico. That was amazing. Just the incredible intricacy of that. We do have a few questions. If anyone has some questions, please submit those to the Q&A or in the chat box. What country were the mechanical birds first created in?
So these were made by Jacques Droz. He was a Swiss maker, but this was actually in London.
Okay, so the original.
So they were Huguenot made originally, but yes, they were born in London.
Okay. Okay, so Suzanne actually asked, please define the fusee versus barrel mechanism.
Okay, so a going barrel mechanism is a mechanism that basically it's a simple barrel that houses a spring. It's what we have in a lot of modern timepieces. A watch, right, it has well, actually all mechanisms were originally fusee driven, but what happened was when the invention of steel came about, steel was not a very reliable material, right? So winding a steel spring up and putting it into a canister, as the spring would unwind, the amount of power that it was able to produce would decline as that spring unwound. It had its most power when it was wound up tightly and coiled. So what would happen was that when you put a spring like that into a mechanism that was supposed to keep time, and your energy would basically slowly start to disperse down, your watch would slow down because it wasn't getting the same amount of power. Same thing with clocks and that nature. So they had to find a way to compensate for the difference in the steel and the power that it was able to give. So what they did was they created something called a fusee, which is a cone. And the cone of the fusee was actually cut to mirror the power curve of the spring. And so there's a chain that wraps around the fusee. So as you wind up your fusee, you're actually winding up your spring. And there's this constant tension between the fusee mechanism and the spring barrel. So you're never running out of a constant power source. One is always balancing out the other. And later on, when spring was more predictable and more able to produce a reliable energy source as it unwound and our manufacturing methods improved, we were able to create just going barrels. So you no longer needed the fusee. And so you just had a barrel with a spring in it. And that barrel was toothed, and it would provide energy to the gear train, and it would continue to distribute that energy in equal intervals throughout the mechanism, or in one equal interval throughout the mechanism. If you're talking about a watch or a clock, you would have an escapement that would distribute that energy equally, right, to your oscillator, which would give you your timekeeping. But in this case, we don't have an oscillator. We just have the performance element of the bird. And in this case, because the spring was more reliable and consistent, you didn't need the fusee. It cut down on production costs and made it much more easy to reproduce that way. And it actually, we simplified the bellows as well, creating wooden bellows, which are much easier to work on than the brass bellows.
Thank you. So here's a very good question. How in the world does you begin to be interested in mechanisms / art and train to be what I think is becoming a magician?
Wow, okay. I mean, okay, sorry. Can you repeat that question so I feel like I have a good way of answering?
Yeah, she's asking how you became interested in what you do and how did you train to become what
okay. Well,
she's characterizing as a magician.
Yeah, thank you. That's very flattering. If I could be anybody, I would be Robert Houdin, who was actually also a clockmaker. But I started out as a horologist enthusiast, I'd say, really as a child, because I collected musical boxes and I really enjoyed those mechanisms and how they worked. And I ended up basically working as a jeweler because I liked working with my hands, and enrolled in watchmaking school after I learned about the invention of automata, really through well, their roots go far back past the Enlightenment and the Renaissance, but some of the most sophisticated items like our Jacques-Dros's automata, the writer, the draftsman, and actually, I'm sorry, I realized that I said London earlier. He was from Geneva. I just got my wires crossed with my favorite automaton, which is the Silver Swan, which was made by James Cox, and that was made in London. Apologies. So, sorry, Geneva. Pierre Jacques-Dros was a watchmaker in Geneva, but he also lived in Paris later. Anyhow, basically from learning about these automata that were created during this time by Pierre Jacques-Dros, I found them to be really fascinating, and I had no idea how to study them. I had come across their origins and some papers about, thinking in the Renaissance and the Enlightenment in my philosophy program. And at that time on Wikipedia, the only thing, or on the internet altogether, the only thing that came up was a Wikipedia page about the defecating duck, which was really one of the earliest complicated automata. This was made by Jacques de Vaucanson, who is a very strange French, what would I call him? He was an inventor and like a chemist and a amateur doctor. He really believed that you could reanimate the organs or bodies. So he became, he was a fascinating character, absolutely incredible, brilliant person. He invented the automatic loom as well later. Sorry, I'm going off on a tangent here, but I learned about his work and I decided that I wanted to try to work with these objects or make these objects as a way to kind of look at philosophy, which was my primary interest, but also working with my hands. And so I enrolled in watchmaking school to learn micromechanics and engineering, and then I went on to 18th century clockmaking school in England. I studied at Wesleyan College, and there I was able to specialize in automata. Which is not part of their program, but if I proved myself as a horologist and a clockmaker and basically found work for myself, I would be able to specialize in automata, which is what I ended up doing. So I was very fortunate to go there, and I got my master's in the conservation of clocks and related dynamic objects, and found myself working with these objects that are a dream come true. They are just, these incredible fantasies of the mind that actually found their way into existence. And how that happened, I don't know, because there's so many terrible things have been made in the world, and we got so lucky when these things came about. They produced just this incredible experience of joy and wonder that other objects don't. That was a long answer.
That was a great answer. How long did it take for the training?
I was in school for 9 years, okay. And I will say I'm still learning every day. It's these objects, because it's not like working on, cars. Maybe it's like working on a Model T. I've never worked on a Model T, but it's each one was handmade, and they had good days and bad days just like we do. So each object carries the good days and the bad days of those people, and heck, they didn't have medical care. Like, gosh, only knows what was going on in their lives. Things go wrong for us, and we have all the privilege in the world of, modern medicine and electricity and science. And, it's just incredible that they were able to do these things. And so each object really is its own little world. And even if you're looking at something made by the same maker, as I was saying, and kind of trying to illustrate with some of those examples, maybe it was made 10 objects later, and even if it was made next to it, the parts are not interchangeable. Each thing was one off. And so while some of them have the same characteristic flaws, like issues in the bellows system, this delicate pneumatic system, each component, was made differently, similarly but differently, because it was handmade.
So how long did the entire restoration process of the Singing Bird box take?
That is a great question. It's actually really hard to estimate exactly how long these things take. I try to keep a clipboard of all my hours, but it took several weeks of 8-hour days getting through that. Because the bellows, like I was saying with the bellows system, what happens is, if something goes wrong inside the system, you can't just address that one issue. You have to start over again. And it could be that the spring doesn't have quite the right tension. It could be that the valve isn't floating the way it's supposed to. It could be that maybe there was a little bunch in the way that the coating went on, the covering went onto the plates. There could be a little gap, right? Any of that will actually cause the system to fail because it's a very delicate pneumatic system. And so when I say maybe it took several weeks, well, I mean, it did, but sometimes it would be because I had to let those bellows dry overnight. So you couldn't, I couldn't just, and each side had to dry separately, because each side has to have a tight seal on it. So you can't glue it all together and let it sit there. You have to make sure that everything is really well sealed. And so that takes several days before you can actually generate a good seal on the bellows.
A somewhat related question to that in terms of the bellows. Regarding the airflow, is it different in each bird musical box? Does the width of the whistle also influence the sound of the bird song? And what influences the length of the singing?
Okay, so yes, the whistle itself will change the sound of the bird song. So the smaller the whistle, the higher the notes will be. And then your whistle, it's like a piston. You can't have any wear inside of there. It's got to have a really strong seal too. Like you literally want that plunger to feel like it's going to be sucked in. It needs to have a really good pressurized system in there. And the length of the song is dictated by that cam stack. Now, when I briefly mentioned Jacob Frizzard, who, if I could meet one person in history, I'd probably want to meet Jacob Frizzard. He was just an incredible maker that basically was the innovator behind creating these incredible cam stacks that allowed the bird to sing longer. And that was because they actually were articulated. And without Jacob Frizzard's contribution, we certainly wouldn't have the incredible mechanisms that we do now. And he went off on his own. I mean, he worked at a lot of different firms. He'd move around, and I think history will support the idea that as he moved from firm to firm and his developments were adopted by these different places, those places, their mechanisms improved. The products that they made were exceptional, partly because of his contribution. But then he went off and went on his own to market his own things. And there's only a few of those things out there, but he died penniless and unknown abroad, which is just terrible.
Oh.
I know.
Yeah.
Anyhow, that was another long answer.
Oh, that's great. Well, we are out of time. But thank you so much. This was really wonderful, really interesting. And thank you everyone for joining us. And the box you can come and see at the museum in the Rare and Wondrous exhibition, and the video that Nico showed us of it in action is also in the exhibition. So you can watch that there too. And thank you again. Really wonderful. Really enjoyed it.
Oh, thank you. Thank you so much. I appreciate you guys also bearing with me in this heat wave we have in Seattle right now. So it's a little bit warm.
Yeah, well, keep cool, I hope. And thank you, everybody.